Hi, this is Mohammad Hasan Algarhy, and today I'm going to be introducing the in sign, which is a new mathematical symbol. So Max Planck quantized energies in multiples of h bar omega. And then came Einstein, said the energy of a photon is h bar omega, and the momentum of the photon is h bar k. So EP equals h bar omega k. Then came de Broglie with the idea that even though this was written for photons, it is valid for particles as well. All particles, and these particles are basically waves. So psi xt equals to e to the power I kx minus omega t. We have the momentum operator equals h bar over I ddx, and the energy operator equals I h bar ddt. So when the energy operator operates on a wave function, we have I h bar ddt psi equals h bar omega psi. And we also have I h bar ddt psi xt equals e psi xt. This equation prescribes how a wave function of energy E evolves in time. It tells you if you know the wave function and it has an energy E, the left side of the equation is how it looks like later. And you can take the derivative on the left side of the equation and solve this differential equation. In this equation, E is a number. You know you have a particle with energy E. That is how it evolves in time. Then came Schrodinger and looked at this equation, which is true for any particle that has energy E. Maybe we don't know what the energy E is, and Schrodinger basically made one single replacement. He introduced one single replacement to this equation by replacing the energy E with the energy operator E with a hat. So he just added a hat on top of this E, replaced the energy with the energy operator. So Schrodinger's equation doesn't assume that the energy is a number because we don't know it. In general, if the particle is moving in a complicated potential, you don't know what the possible energies are. So the equation became I h bar ddt psi xt equals the energy operator psi xt. This what must be happening anyway, because if this particle has a definite energy, then the energy operator E gives you the energy acting on this function. So what if the particle doesn't have a definite energy? What if the energy operator is operating on a complicated potential, or in other words, a field of waves, which is fundamentally how energy operates? Energy doesn't operate on a single wave. It operates on a field of waves, on a complicated potential, basically. The energy operator requires the freedom to act on the operatee's multiple quantum states. Both the operator and the operatee can affect each other. So this requires the freedom to swap roles. So additionally, it would be required to include other operations being acted upon by the energy operator, not just position and time. So how can we do that? How we can find a mathematical tool, a mathematical symbol, a mathematical notation that allows us basically to do this operation, to have this kind of freedom, the freedom to swap roles between the operator and the thing that the energy is operating on. I'm calling it here the operatee. So what we will do is that we will follow Schrodinger's lead, and we will do one simple addition, which is this sign right here. And we will call it the in sign. I chose this notation for it. Adding this sign defines and enables this kind of operation. It gives us the freedom to swap roles, and the equation here is prescribing that the energy operator is acting in a wave function, which is the operatee in this case, and this wave function doesn't have a definite energy. It could be a field of waves. This equation also prescribes that the energy operator and the wave operatee affect each other and can swap roles. So far, we are trying to understand how the wave function evolves in time. What if we want to understand how the wave function evolves relative to other factors, like shape, for example? This shape could be itself evolving in time and could be time independent. These are predefined conditions that we should define before carrying out the the operation. So let's look at it from a different perspective. This one right here, energy in shape gives you a wave function. So the energy operator in shape, and I added a hat here because the shape could be the operator and could be the operatee as well. The energy operator in S shape, operator and operatee, gives you F psi xt. I added a hat here on top of the psi to show that this could be as well a complicated potential, a field of waves that could be the operator and could be the operatee. So here, E is the energy operator, S is the shape operatee, and F psi xt is the resulting wave function. This proposed equation prescribes that energy in shape gives a wave function, which could be applied in principle to almost everything. However, there should be predefined conditions in order to get more specific information and solve more specific problems. The concept of the shape as an operatee or even an operator in this proposed equation goes beyond the conventional shapes of topological spaces construction of new topologies from given topologies, topological manifolds and bundles, etc., which is a big area that could be explored. The idea is that shape or spaces acts as a container for energy. Energy can operate on the shape and change it, and vice versa. Shape can operate on energy and change its frequencies. The shapes concept also goes beyond even further to the idea of patterns, which is discussed in my book as well, Quantizing Emotions, the Basic Mathematics of Psychology, which was published back in Feb 2021. So the resulting wave function, let's call it the in product, should be considered an operator. In this proposed equation, we have the freedom to swap the in product, the operator, and the operatee. In other words, the energy operator could act on the wave function to give a specific shape or topological manifold. So the equation would be E, the energy operator, in the wave function, F psi with a hat, xt equals to shape with a hat. Swapping the roles of the operator, operatee, and the in product is a fundamental principle that could be useful in many conditions and various states. This is a very important and crucial principle, which is basically swapping the ability to swap the roles of the operator, operatee, and the in product. And this is a key operation or a key function that the in product is doing, giving us the freedom to swap roles of the operator, operatee, and the in product. This idea is not too exotic from superstring theory, for example. T-duality in superstring theory, we see T-duality is interchanging the W, which is the winding number, and the N, which is the momentum. So in my proposed equation that I just mentioned right here, the energy operator in shape gives you a function, a wave function, F psi with a hat xt. And the energy operator is comparable to the momentum in superstring theory, and the wave function is comparable to the winding number if we want to compare it to superstring theory. So shapes form patterns. The proposed concept could be applied to patterns as well, where the movement, or rather the fluctuations of energy or complicated potential of energies in a particular pattern creates a specific function or a wave function. So it could be written as well, E, the energy operator, in PA. So PA with a hat here refers to a pattern that could be the operator and could be the operatee as well. So the energy could operate on a pattern, and the pattern could operate on an energy and change it as well. So the energy operator in a pattern would give us a wave function F psi with a hat xt as well, where PA refers to the pattern in which the energy operator moves. Following the same logic, the operator can affect the operatee and vice versa. So the freedom to swap the in product, the operator, and the operatee, in other words, the energy operator could act on the wave function to give a certain pattern. In that case, the equation would be swapped as well. So energy operator in a wave function, F psi with a hat xt, gives you a pattern, PA. If you have my book, you will see that this equation was written as E in P, So I initially wrote it as P, but now I modified to PA in order not to confuse it with momentum and the momentum operator. And if I ever wrote a new edition, a second edition of my book, I'll modify it to PA in order to avoid confusing it with the momentum operator. So an example of the geometrical pattern is what we can consider as the energy pattern in which the atoms are arranged in a molecule. This pattern is giving the molecule its function. The atom is formed of a specific pattern of electrons and more fundamental particles. The change in this pattern due to a change in energy can change the function and lead to a different molecule. Let's go back to the idea that a particle could be considered a collapsed wave function. Could the collapse of the wave function target a specific pattern to stabilize and carry out a targeted function? So back to the equation that we mentioned, the energy operator in a pattern gives us f psi xt. In some cases, the energy operator in this equation might not affect and could be considered negligible in some situations. This means that only the pattern can lead to a specific function. This is analogous to the atom and the molecule story. When atoms are joined in specific geometrical patterns, we get a particular substance's molecule. If the same types of atoms are joined in a different geometrical configuration or pattern, we get different kinds of molecules of other substances. In this case, the energy of the atoms played no role, and the specific function or substance was formed just based on the geometrical pattern or configurations. So, the effect of the patterns on the resulting molecule could be directly measured and understood as we can study which pattern of atoms leads to which molecules, and hence which types of substance. Accordingly, we can understand which patterns lead to which sort of functions. So, every electron's location and energy in an atom is determined by a set of 4 quantum numbers that describe different atomic orbitals. So, an orbital is a region of probability where an electron can be found. So these 4 quantum numbers are: n is the principal quantum number telling us the energy level, L is the azimuthal quantum number that tells us the orbital type and angular momentum, ML is the magnetic quantum number which tells us which specific orbital amongst the set and the projection of the angular momentum, MS is the spin quantum number that tells us the spin. Each electron in an atom has a unique set of quantum numbers. The quantum numbers describe the pattern and the effect of this pattern. In other words, the pattern led to a certain function. You will find more details about how I built the logic for this and for introducing the in sign to the Schrodinger's equation and the idea of swapping roles and so forth in my book, Quantizing Emotions, the Basic Mathematics of Psychology. Thank you so much.